Hello everyone, in this video we will study about arrays and its fundamentals. Arrays is basically a simple data structure that can also be used to build complex or composite data structures like stacks and queues. In this video we will discuss about arrays and we will see what all different operations can be performed using arrays and how arrays are stored in computer's memory. So let's start with the definition of arrays. Arrays is a collection or systematic arrangement of objects of same data types. Data types can be integer, character, double, etc. Now let's say if we want to declare an integer array, then let's see how we will do that. We will first write the data type, then the variable name, and then the size of the array. So this is the data type, which can be character, float, double, etc. This is the variable name, and this is the size of the array. Now let's see where the concept of array is useful in computer programming. So let's take a case where we have to store marks of 10 students in the class, and we have to find the average marks of all the students in the class. So if we use the integer variables, we can have 10 different integer variables m1, m2, m3, m4 and so on up till m10, where each variable corresponds to the marks of the student in the class. And in order to find the average, first we need to find the sum of marks, which can be calculated using m1 plus m2 plus m3 plus m4 and so on up till m10. Then we can easily find the average using the formula sum divided the size, that is 10 in our case because the class has 10 students. Now let's say instead of 10 students, if we have 100 students in the class, then you can easily see that it will be very difficult to have 100 different variables. So instead of that, we can easily form an array of data type integer and size 100. We know the indexing of the array starts from 0. So M0 will represent the marks of first student in the class. M1 will represent the marks of second student in the class. M2 will represent the marks of third student in the class up till M99, which will represent the marks of 100th student in the class. Also, you can see that to find the sum using M0 plus M1 plus M2 up till M99 will also not be a good idea. So instead of that, we can easily run a for loop, and let's see. So first we will have sum array, which will be initialized to 0. Then we can run a for loop, which is starting from 0 and going till 99. And we can easily update sum as sum plus marks of ith student. And in order to find the average, we can again use the same formula, which is sum divided by total number of students in the class, which is 100. You can clearly see that it will work even if the class has 1000 students or even more than that. So this is a clear example how arrays are very useful. We can also have arrays of different data types. So in this case, we are declaring an array of integer data type, but we can also have arrays of character, float, and so on of different data types. And also this is an example of one-dimensional array, but we can have arrays of 2-dimension, 3-dimension, and so on. Now let us see how arrays are stored in computer's memory. So computer memory is divided into segments or partition, and computer memory can be considered as a very large array of bytes. So each segment is representing 1 byte of memory, and in computer architecture, each byte of memory has an address. So we can assume the bottommost address is 0. Then as we go up, we have address 1, address 2 and so on. So let's take address of this byte as 100, then this as 101, then this as 102 and so on. In C and C++, we also have pointer variables that can store these address. Now let us take our array again. So we have an array of data type integer and let's take the size 5. We know the size of integer is 4 bytes and the total number of elements in our array is 5 and every element is having 4 bytes. So total size of the array becomes 20 bytes. Now when the program executes, the computer will allocate 20 bytes to this array. So you can assume that this 4 bytes will be given to A of 0 and computer will give continuous segments. So basically array of 1 will definitely have these 4 bytes, array of 2 will have above this and so on. Now since memory allocation is continuous, so access and modification of the array element becomes very easy, and the access or modification of the array element takes order of 1 time. That is order of 1 time complexity. Now let us see how. So basically arrays A is also known as the pointer to the first element of the array. And A also represents the base address. So let us see using a C program how we can see the value of address and the value stored at that particular address. So let us go to a C program and let's declare the integer array of size 5. Now if you will execute this statement printf %d is used for integers, \n is used for next line, and you will try to print A, this will print the base address or the address of first element of the array. And also if you will try to print the value at this address, which will also be an integer, you know in C we can print the values using x star. So star A will print the value of first element of the array. Now we see that we have only declared the array. We have not initialized the array. So at this point of time, this will print a garbage value or any random value. So if we want to test it properly, let's also initialize the array. So array of 0, let's make it equal to 2. Array of 1, let's make it equal to 4. Array of 2, let's make it equal to 5. Array of 3, let's make it equal to 8. And array of 1, let's make it equal to 1. Now if you will print this again, the base address will be printed, but the value will not be any random value. Instead, this will print 2, which is the value of the first element of the array or the index 0. Now, if you will try to execute a statement like this, that is the address of the next element, that is A plus 1, this will give you the address of the next element, that is second element. Now, let's say if the value of base address is 100, this will return the value 104. Why? Because this is a pointer to the first element of the array, that is base address, and this is known as the offset. Now offset increase the address of the base address by the size of the data type. In our case, we are using an integer variable. Integer has size 4 bytes. So this will increase the address by 4 bytes. So if the base was 100, in this case, 104 will be printed. Now, as we mentioned, the SS is in order of 1. So let's say if we have to print the second value or the value of second element, we can easily run this, which will be an integer because we are having an integer array. An * sign we know is used to print the value of particular address. So this statement will print the value of the second element, which we can clearly see is 4 in our case. Now, SS is order of 1 because, as we have seen, when we want to try or we want to find any element in the array, the address is calculated using base address plus the offset. So let's take an example. If we have to find the value of the third element of the array, we can either write it like this, that is value basically of the fourth element, which is the third index, and it can also be seen like this, that is base address plus the offset and the value at that offset. Now, please note that the pointer arithmetics only applies in C and C++ because Java do not support pointer variables, but the internal working will be similar. So this was the basics of arrays and how they are stored in memory. In coming videos, we will study more about arrays. So I hope this video was helpful and thank you everyone.
So my name is Kshitij and I will be discussing about arrays in today's class. Okay. So in today's class, we are going to discuss some challenging problems on arrays, which can be solved just by the knowledge of arrays. In tomorrow's class, we'll be discussing some more challenging problems on 2D arrays, and then in the upcoming classes, we'll be discussing about sorting. Okay. So in the next 4 or 5 classes, we'll be discussing about arrays and sorting algorithms. Okay. So before we start the class, I just want your opinion on have you guys ever worked with arrays? Have you guys ever used arrays? Are you guys familiar with what is an array? Arrays are nothing but collection of same type of data, right? You can have an array of integers, you can have an array of strings, you can have an array of floating point data structure, or you can even have an array of objects, right? So array is nothing but a collection of data, and arrays, all the values in the arrays are stored in continuous memory locations, right? So if you have an array A of size 5, and if this is your memory, all these array elements are going to be stored in continuous memory chunks, right? So they are always in a sequence. Correct. Homogeneous collection of data. Absolutely correct. Okay. Now, in today's class, we are going to see some of the problems which do not require any algorithm, which do not require knowledge of any other data structure other than arrays. Okay. And these problems have been asked in Google, they have been asked in Facebook, they have been asked in Amazon. So if you are just familiar with arrays and if you have a basic logic building or problem solving skills, you can attempt these problems. Okay. Right. So regarding the language, so most of you are asking in which language are we going to discuss the problems, right? So let's keep the session language agnostic. Okay, we'll be discussing the logic, we will be discussing the pseudo code, but all the logics that we are going to discuss, they will be language agnostic. So whether you are coding with C, C++, Java, Python, Ruby, doesn't matter. You can apply those logics, you can apply the same solution in any language. Okay, so keep things language agnostic and let's focus on the problem solving techniques. Okay, one more thing guys, that with the class you will also be getting the problems that we are going to discuss. You will get the exact same problems, you will also get some variations of these problems. Okay, so that you can test your knowledge there, right? So I strongly recommend all of you to attempt those problems. Because if you are just listening in the class and you feel that you have understood everything, you might understand things, but after a while you will forget. So it's always better to reinforce your knowledge by practicing those problems. Okay, so I will strongly recommend you guys to solve all the problems which are provided in the description link. Okay, cool. So let us start this session with a very interesting problem, and this problem was asked in Amazon. This has been asked in Facebook. This has been asked in Google. Okay, the problem says that you are given an array, and in this array you are having heights of some buildings. Okay, so you can consider that these are 2D buildings, two-dimensional buildings with a width of size 1, and the height is given to you in an array. Okay, so let's say that this is the array in which you have all the heights of the buildings. Okay, now you can see this picture. So these are the buildings, right? And these black bars are the buildings, and it's raining heavily in this city. So you have got some clouds, and it's actually raining heavily. And because of the rain, there is some water which is being trapped between the buildings. Okay, so these are the clouds, not so good looking clouds, but yes, there are clouds. And you can see some water being trapped in between the buildings. So given the heights of the buildings, you have to identify what is the total amount of water which is being trapped in between these buildings. Okay, is the problem making sense? तो आप लोगों को एरे में बिल्डिंग्स या बार्स की हाइट दिए हुए हैं, एंड वहां पे शहर में बहुत तेज बारिश हो रही है, तो चूंकि ये 2 डायमेंशनल वर्ल्ड है, यहाँ पर कुछ वाटर ट्रैप हो रहा है इन बिल्डिंग्स के बीच में. ओके, आपको बताना है कि टोटल कितना अमाउंट है वाटर का जो कि ट्रैप हो रहा है. ओके, राइट, दिस इज अ वेरी फेमस प्रॉब्लम. इट इज कॉल्ड ट्रैपिंग रेन वाटर. This is a problem which is present in each and every platform. This is in LeetCode, this is in Interview Bit, this is in Geeks for Geeks, this is in HackerRank. This is present in each and every platform because this is very frequently asked problem, right? So what is the answer for this case? Here we can see that 6 units of water is being trapped, right? 1 unit here, then you have 1 unit here, 1 unit here. So let's actually draw the squares, right? This is 1 unit of water. Then you have 1 unit of water here. Then you have 1 unit of water here, 1 unit here, 1 unit here, and 1 unit here, right? So you have got 6 units of water being trapped between these buildings here. Okay. Now the question is that given the array, you have to identify, you have to calculate the total amount. Okay. How to approach this problem? Okay. So there is focus on what is contributing to the total amount. How do we calculate the total amount? So how have we counted the total amount of water in this case? To count the total amount of water, what have we done? We have just counted what is the amount of water trapped above each and every bar, right? So if I count what is the total amount of water trapped above each and every bar, and if I just add that, that would be the answer. For example, here this bar length is 0, so this bar is having 0 amount of water trapped. Here the bar length is 1, but even then the amount of water trapped above it is 0. Here the amount of water trapped above this bar of length 0 is 1. Right? Similarly, here we have 0 amount of water. Above this bar we have 1 unit of water, right? Similarly, above this bar we have 2 units of water. Here we have 1, then again 0, 0, then 1, 0, and 0. So if we just add all of these, we'll get the answer. If we just add the amount of water or the size of the water column trapped above each and every building, we get the answer. Now the question is how to get the amount of water trapped above each and every bar, right? So we have reduced the problem from finding the total amount of water to count what is the amount of water trapped above each and every bar. But how to do that? Okay, again, let's make some more observations here. Okay, so we have seen that the amount trapped above this bar is 0. Okay, why is this amount 0? Why is it not non-zero? Why is this amount, why is this bar not able to trap any amount of water above it? Simple reason is that there is nothing on the left side to hold the water, right? There is something on the right side, but if the water falls here, there is nothing on the left to hold it, right? If there had been a bar on the left side, then you would be getting some water here, but there is nothing on the left side. So you can just consider this as a vessel which is of this L shape, right? You can consider this scenario as a L-shaped vessel. If you fill any liquid inside a L-shaped vessel, it will just flow from here, right? You cannot trap the liquid with in a vessel which does not have the boundary, right? So that's why here we have 0 amount of water. Now, what about this bar? This also has 0 amount of water. What is the reason for that? This is not 1. This has to be 0. What is the reason for this? Again, the same reason. This bar also does not have anything on the left side to hold the water, right? That's why this is also not trapping anything. When we come to this bar has got a size 0, but it is able to trap a water column of height 1. Simple reason being, it has got something on the left and something on the right as well. So now this is forming a complete vessel, right? So it can hold water, a water column of size 1. Now we come to this bar again. This has got a bar which is on the left side, right? If I'm talking about this bar here, this has got a bar on the left side. Even after that, this bar is not able to hold any water. Why? Because the bar which we have on the left side has got a smaller height, right? If you have to hold some water above this bar, you need something on the left and something on the right of a higher height, right? So you can assume that this is the surface of your vessel. Now, this bar here is below the surface, right? So you need something which is higher the surface. Then only you can trap some water inside this, correct? So that is why this is also not able to trap anything. Now, when you come here, this has got something on the left and something on the right as well, correct? So one thing which is very clear from this observation is that to trap the water, you definitely need something on the left side, something on the right side of a higher height than the current bar, right? This bar is not able to trap because it doesn't have anything on the left. This bar is able to trap because it has a support on the left side as well as on the right side. So it has got both the boundaries, correct? Cool. Now the question is, how do we? So we have determined that some of the bars will not be able to hold, but the bars which are holding the water, how much water is going to be there? Okay. Now to do that, to actually analyze that, let's consider a very simple example first. Okay. So let's say that the heights of the bars are 2, 1, and 3. So we have got a bar of size 2. Then we have got a bar of size 1, and then we have got a bar of size 3. And we are talking about this middle bar. We have to identify what is the amount of water being trapped above this middle bar. Okay. This has got height 2, this has got height 1, this has got height. Can you guys quickly respond? What is the amount of water which will be trapped above this bar? The size of the water column here. Is it going to be 1? Is it going to be 2? Is it going to be 3? It's going to be 1, right? Why 1? Because the height on the left side is this height is of size 2, right? And we have this bar till height 1. So the only limited space that we have for the water is this column. Anything above it will flow from here, correct? Okay. Let's change the example. Let's add some more bars here. Okay, so initially we have this configuration where we have bar of size 2, 1, and 3. Now I'm going to add one more bar on the left side, and this bar is also of length 3. Now how much water will be trapped above this bar? Is it still going to be 1, or now will we have some more water here? Yes, it's going to be 2 this time. Why? because now we have got a higher support on the left side, right? So if it is continuously raining, all this area will be filled with water, right? And now we can see that this column, the height of this column has now become 2, right? The height of the water column trapped above this bar has now become 2. Height of the water column above this bar has now become 2. Okay. Why has it become 2? In this case, it was 1. Now it has become 2. What is the reason? What is the reason? The reason is the addition of this bar. Right? Let's add some more bars. Okay. Let us add some more bars to this configuration. So I will be adding a bar on the left side. Let's raise a bar of size 4. Will the height of the water column stored above this will increase? If I have just added a bar on the right side of length 4, will the height of the water column above this bar, is it going to increase? No, right? Because on the left side, it is still 3. On the left side, the maximum that we can have is still 3. Anything above it is going to flow from here. If we also add another bar of size 4 on the left side as well, now will it increase? Yes, now it's going to increase because from both the sides we have got a height of size 4, right? So is this complete observation making sense to you guys? The height of the water column stored above any height is nothing but the minimum of the maximum height that you can get on the left side and the maximum height that you can get on the right side, correct? The height of the water column stored above this is minimum of maximum height available on right and maximum height available on the left. So if I have to identify what is the height of this column, right? Height of water column above bar I, this is equal to, this is nothing but the minimum of maximum bar on left side, maximum bar on right side, minus the height of bar I. So if I'm talking about, if this is my ith bar, the water column trapped above this bar is how much? This is minimum of maximum of left, maximum of right, minus the height of this current bar. If I have to calculate the total amount of water, this is just going to be the sum of all such values, correct? So the answer that we are going to calculate, sum of this value for each and every height, right? Sum of minimum of left max, right max, minus height of bar. So I will be calculating the minimum of left max, minimum and right max for each and every bar, subtract the height of that bar and keep adding it. So whatever we get at the end is going to be the answer, correct? Let's quickly do this thing on the given example, right? What is the minimum? What is the minimum on the left side for this? Minimum on the left side for the first bar is 0. There is nothing on the left. Sorry, maximum on the left side, right? Maximum on the right side is this bar of length 3. But since we are taking the minimum of left max and right max, minimum becomes 0. 0 minus the height of the bar is 0, right? So this is not going to hold anything. What about the first one? Again, left max is minimum. Left max is 0. So we won't be getting anything, right? For this bar, for this water column, the left max is 1, right? The right max is 3. So minimum of left and right is 1 minus the height of this bar, which is 0. So this is going to hold 1 unit of water, right? So if we do the same thing for each and every bar, we are going to get the answer. Let's also see for this column. So here, what is the left max? Left max has got a height 2. Right max has got a height 3. Minimum of 2 and 3 is 2. Right? So this bar is going to hold 2 minus the height of this, which is 0, this much amount of water. So we just have to do this thing for each and every bar, and we add whatever amount is trapped over that bar, and we get the answer. Okay. Okay, let's do this in this example. Let me just clean it up a bit. Let's try to calculate what is the total amount of water that will be trapped in this scenario. Okay, if this is the landscape of the buildings that we have, what will be the total amount of water trapped here? Okay, so we are saying that the total amount of water trapped is the sum of water trapped above each and every building. What if negative? Heights are not going to be negative, right? Negative height means that you are digging a hole and then you are, so it's basically kind of a plane. So you can assume that such buildings with negative heights are not possible, okay? Okay, let's try to run our approach on this thing, okay, on this scenario. So for this building, what is the maximum height on left side? Maximum height on left is 0. Maximum height on right is 4. For the first building, the answer is going to be 0, right? For the second building, maximum height on right is 4. Maximum height on left is 4. Maximum height on right is also 4, right? So we'll be getting minimum of these two minus whatever is the height of the building, which is 3. So this is going to contribute 1 unit of water, okay? Then in the next building, so the 1 unit of water comes here. In the next building, we will be checking minimum of what is the left max. Left max is still 4. What is the right max? Right max is still 4. Building size is 2. So we get 2 units of water above this. Okay. Similarly, for the next buildings, again, left max, right max are 4 and 4. Building height is 1. So we get 3 units of water above this. Okay. Similarly, we'll be doing for this as well and this as well. And once we add all these values, we'll be getting the answer. Okay. Cool. So now once this is clear to everyone, can you guys tell me what is going to be the time complexity of this approach? So for every bar, we are calculating a maximum on the left side. We are calculating the maximum on the right side. And then we are applying this observation and getting the height. What should be the time complexity if we go by this approach? Okay, let me just reiterate over this example again. For if I'm calculating for this bar, I will have to calculate what is the left maximum. To calculate the left maximum, I will be iterating over all the possible bars on the left side. To calculate the right maximum, I will be iterating over all possible bars on the right side. How much time is this operation going to take? This is going to take order n. How much time is this operation going to take? This is also going to take order n, right? So to calculate the water column above each and every bar, we are doing an order n operation because these two are going to get added, right? And we are going to do this operation for each and every bar. There are n bars in total. If there are n bars and for every bar, our calculation requires order n time complexity. What is going to be the total time complexity? Right, so there are n bars. For every bar, we are going to do order n operations. So the total time complexity is going to be order n squared. Okay. Can we optimize this order n time complexity? In the last class, you must have learned that order n is not a very good time complexity, right? Yes, Vijender, you are absolutely correct. Right, guys. So to optimize the time complexity, again, let's make a very simple observation, right? So till now, we have deduced that for every bar, we have to calculate the left max and the right max. Okay. Let's talk about the last bar. Okay. If I'm talking about the last bar, then we are calculating the left max for the last bar. How actually we calculate the maximum for this? The order and operation of the maximum, of finding the maximum. How do we run it? So we will be declaring a max, right? And we'll keep updating it after visiting each and every bar. So we'll initialize a maximum value. We can initialize it with a with maybe minus infinity or maybe a not possible or 0. Maybe we can also initialize it with the length of the first bar. Okay. So we say that currently the maximum is this and we'll keep updating the maximum as soon as we visit all the bars in this order and loop, right? So if let's actually take a complex example. So if the bars are of size 2, 3, 1, 4, 5, 2, 1, 7, okay, 2, 9. If these are the lengths of the bars, if I have to calculate the maximum from left for this last bar, right, I will be starting from here. Okay, let's initialize the maximum with 0. Okay, so we are saying that whatever is the maximum between the current maximum and the current bar is going to become the maximum, right? So maximum is initialized by 0. When we reach here, we say that 2 is the maximum. Then when we reach here at 3, we compare this value with the current maximum, right? This is how we calculate the maximum of an array, correct? So we calculate current value of the array with the current maximum. So 3 becomes the maximum. Then we compare this 1 with the current max. Let's call it the current max. Okay. Again, 3 remains the maximum. So we'll fill 3 here. So this means that till here, till this point, 3 has got the maximum height, right? Now similarly, for the next step, we'll be comparing 4 with 3. Okay, so this gives us 4 as the maximum, then it gives 5, and then we'll be having 5, 5 till this point. Then we get 7, and then 7 continues to here. So the maximum for on the left side for this bar is 7. Okay. Now in this process, if you have observed, what have we done? We have not only computed the max for the last bar, but we have also computed the left max for each and every bar. So if you just store all these values in an array, instead of just keeping a variable of the current max, if you just have an array and store all these values inside the array, these values are corresponding to the maximum height on the left side for each and every index. Is this making sense? Till this point, 5 is the maximum. Till this point, again 5 is the maximum. Right? Till this point, 7 is the maximum. So while you are calculating the maximum value for the last bar, you have not only calculated the maximum on left for the last, but you have also calculated the maximum for each and every index. So in a single iteration, we have the values of left max for each and every value. Okay, let me just repeat. Let's clear each and everything here. Let's do it once again. Okay, so when we have to calculate the maximum on the left for the last bar, first of all, is everyone clear that we'll be calculating the left max for each and every bar and right max for each and every bar? Yes. Now, let's talk about this guy. Let's talk about this bar. If you have to calculate the left max, you will be iterating over this part of the array, right? You will maintain a left max for this bar, and you will keep updating that left max while visiting the array, right? You will initialize a left max with 0. You will check whether 0 is greater or this value is greater, right? So you will keep updating this left max while while iterating over the array. Similarly, you will do the same thing for the right max as well, correct? Now let's talk about the last element. Let's not talk about the middle element. Let's talk about the last element. When we are doing it for the last element, we are actually calculating the left max for each and every index, right? Left max till now is 0, right? Or let's call it 2 here. So we have initialized the left max by 0. We compare it with 2, we get 2 here, then we get 3 here, right? Then we get 3 again here, then we get 4 here, 5 here, 5 continues till we get a longer height which is 7, right? And again we get 7 here. What if 9 is not present? Then also you do the same thing. If 9 is not present, you have 1 bar less in your structure. Then you will be, when you calculate the left max for the last index, doesn't matter whether it is 9 or any other number. When you are calculating the left max for the last index, you have actually calculated the left max for each and every index in this process. The only thing is that you will have to store these values. Instead of updating the current max variable, if you just store these values in the array, you get the left max for each and every index. Similarly, while calculating the right max for this index, the first index, you will be calculating the right max for each and every value. Correct? Because to calculate the right max for the first index, you will be iterating from the right side, and you will keep updating all the values one by one, right? So you start from here till now the max is 2, then you get 7, and then 7 continues to be the max till now. Okay. So is this observation making sense? The observation is that we don't need to run this order n loop for each and every index, because when you are calculating the left max for the rightmost element and when you are calculating the right max for the leftmost element, you are essentially calculating each and every value which is required in this calculation. So instead of running these two loops of order n on each and every index, what we can do is we can just run a single loop and we can store all the required data. We can do some pre-computation. Okay, we need two extra arrays. Yes, we will be needing two extra arrays. Let's call this array as the left max array, and let's call this array as the right max array. Okay, if we have stored these values, can you guys now tell me what will be the amount of water stored over any ith index, stored over any ith bar? If I talk about this bar, what will be the answer? What will be the amount of water stored over this bar? We need the maximum bar. We need the maximum bar on the left side of this. From where can we get it? The maximum bar on left side of this bar is here, right? We have already calculated it. The maximum bar on the right side of this bar is present here. If we are talking about the ith index, the left max is stored at left max I minus 1, and the right max is stored at right max I plus 1. Okay, you don't need to run two loops for each and every number. We can just pre-compute the left max and right max for each and every index, and using these values, now we can have a different loop and we can get these values in order 1. Okay, what if we store in the ith index itself? Will that work? That will definitely work, Anushka. You will just have to check. Like you can also store for every ith index. You can store what is the left max height at this index and right max height at this index. You will just have to calculate. You will have to this. You will have to keep check on the corner cases. Okay, if you are able to keep checks on the corner cases, then that will also work. Okay, so let's quickly see the pseudo board. Okay, so we can have a left max array. Okay, what will be the size of this array? Size of the array is going to be same as the size of the input array, because for each and every index you want this information, right? So its size should be equal to n, whatever is the size of the input array, correct? And similarly, we'll also be having a right max array, which will store the right max for each and every part. Okay. Then let us initialize these values. So we can say that left max of 0 can be initialized from the array 0. Okay, and right max of okay, let's come to the right max after we finish this, right? So we have initialized this for the 0th index. That means I'm saying that for 0th index, this is the answer. The height of the bar is the answer. Now for the remaining bars, we can just run a loop, which will start from some point, go till n, and we'll be doing it. From where should we start the loop? Should it start from 0? Should it start from any other number? Yes, the loop is going to start from index 1, because we have already filled the value on index 0. So we don't need to start from index 0. Okay. And for every index, we can say that left max of I is nothing but the maximum of the previous max, which is left max of I minus 1, and the current array value, the current height. So whatever is the maximum between the current height, right, between the current height and the previous is going to be the left max of this iteration. Okay. Similarly, for the next value of I, we'll be comparing this value and this value. Okay. So we have our left max array filled up. Now we'll also initialize the right max array. So for the right max array, how did we start? We started from the right side, right? We said that we are starting from here, and let's copy the array value, the last array value in the last index of the right max array, because for this value there is nothing on the right side. So we are starting from here. Okay. So right max of n minus 1 is going to be array of n minus 1. And now similarly we can have a loop which will also start from some number, go till 0, and this is going to run from right to left. So that's why we are doing I minus 1. So from where should we start it? This loop will start from n minus 1. We have already filled the value for n minus 1, right? So this should not start from n minus 1. N minus 1 is some value which is pre-required to compute the value at this index. So we'll be starting from the index n minus 2. Right? To calculate the value here, we need to compare this value, which is the previously calculated value, and the current height. Okay. So let's go back here. We'll be starting this from n minus 2, and right max of I is going to be the maximum of what will come here? Yes, it should be I plus 1, because now when I'm checking for this index, I'm comparing this value. If this is index I, this is I plus 1, not I minus 1. In case of left max, we were comparing with the previous index. Now we are comparing with the next index, right? So this is going to be right of I plus 1 and the current array value. Okay. So now we have got the left max and the right max array populated. Okay, now we just have to run a single loop to calculate the total amount of water trapped. So you can have a variable water initialized with 0, and now we can run a loop, and this loop should run for each and every height. So we'll start from I equals to 0 less than n. We'll be incrementing the I with 1, and we can simply say keep adding the amount of water trapped over each and every bar in this variable. So water plus equals to, or you can also write it as water equals to water plus the, how do we calculate the height of water column? Minimum of left max, right max, right, minus the array value I. Cool. What is the time complexity of this approach? Time complexity of this is, see, first in this code, first we are populating the left max array. For each and every bar, we need what is the left max. So this is going to count order n, plus this array, this loop is also going to be of order n, plus this loop is also going to cost order n, right? So the total time complexity of this approach is order. Yes, order 3n, which asymptotically is same as order n, right? Order 3n is nothing but this is same as order n, because when you calculate the time complexity, you ignore the constants, right? Edge case missed, right? So if this is just a pseudo code, okay, now you have to attempt this problem, you have to solve it on your own, and in the code which you are writing, you have to take care of all the edge cases as well. Okay, Himanshu, that is on you now, so you have to do it on your own. Okay, what is the space complexity, guys? Can you tell me what is the space complexity? We are using two arrays of size n, right? So it is going to be order n in space as well. Okay, let's do one thing. Let me just tell you the problem. Okay, this is also a very interesting and very frequently asked problem, which is called the majority element. The problem says that you are given an array. You have to find the majority element in that array. The majority element is the element that occurs more than n by 2 times. Okay, which means that the number of times that element is occurring in the array should be strictly greater than n by 2. For example, if this is your array 3, 3, 4, 2, 4, 4, 2, 4, 4. Can you guys quickly tell me what is the majority element in this array? N, which is the size of the array. What is the size of the array in this case? 9, right? Now, which is the element which is coming more than 9 by 2 times? Correct. Majority element in this case is 4, because 4 is occurring 5 times. Okay. 4 is the majority element here because 4 occurs 5 times. Let's take another example. Let's say we have 3, 3, 4, 2, 4, 4, 2, 4. What is the majority element in this case? Size of the array is 8. What is the majority element which is occurring more than 4 times in this case? 4 is occurring 4 times, right? But we need something which occurs more than n by 2 times. 4 is not more than 2. So in this case, we do not have any majority element. Okay? No majority element. So you have to, if there is a majority element, you have to return that element. If there is none, you can return none. Okay? This is the problem. Is the problem clear to everyone? What would be a brute force way to solve this problem? What if two elements are majority elements in the same array? Guys, that is a very interesting thing that Satyam has asked. Can there be two majority elements inside a single array? Satyam, think about it. Can there be two elements which are occurring more than n by 2 times? No, right? How 4 is greater? 4 is not greater than this, but the count of 4 is 5. Right? We have to count the number of times this element is occurring. We don't have to return the element which is greater than n by 2. We have to count the number which is occurring more than n by 2 times. Okay. Cool. So what is going to be the brute force solution here? Brute force solution is going to be simply you run two loops for each and every element. You just check whether that element is a majority element or not. Select this element. In the remaining array, count the number of occurrences. If the total number of occurrences is greater than n by 2, return it. Otherwise, go to the next element. Check for this element in the remaining array. If it is occurring more than n by 2 times, return. What is going to be this time complexity of this approach? It's going to be order n square. Why? Because you are running two loops of size n. Correct? Okay, so brute force is not going to work. This is too slow. How can we optimize it? Using hash map, right? So some of you are saying that we can use hash maps. If you use a hash map, first of all, how can we solve this problem using a hash map? So this is a very good suggestion that use a. What is hash map? Is everyone clear with that? If you are not clear, you can skip this. If you are clear, you can think in this direction. Hash map is nothing but a key value pair, right? So you can have a key and you can have a value in the hash map. Now every array element becomes the key and the frequency becomes the value. So against 3, you keep 1. Then you again go to 3. You see that 3 has already occurred in the hash map. You increase the frequency. Okay. Then you go to 4. 4 is not occurred yet. You keep it and you put 1 here. So after you have iterated all the array, yes, it's totally like the dictionary in Python. Okay. After you have iterated all the array, you will be having all the array elements along with their frequencies. Okay. So 4 will be 5 at the end because the frequency of 4 is going to be 5. And the frequency of P is going to be 2 and 2 is also going to be 2. This is the value, the array element, and this is the frequency. After you have made this complete map, you can iterate over all the keys and you can figure out which of them is the majority element. This is one of the approach. What is going to be the time complexity of this approach? If you are not aware about what is a hash map, you can totally skip it. We will be covering hash map in details in the upcoming sessions. But if you are clear about hash map, then you can just think about what is the time complexity of this approach. This is going to be order and time complexity, correct? What is the space complexity here? You are using a hash map which is going to cost you order and space, right? Order and time complexity plus order and space complexity. Okay. You have to solve this problem in a linear time with constant space. Okay, this has to be your time complexity, this has to be your space complexity. Is the requirement clear to everyone? You cannot use a hash map. If you are not clear about the hash map approach, completely skip it, because this is something that you cannot use in the question. Okay, you have to solve this problem in order and time complexity, order one, space complexity. Okay, think about it. This is going to be something which we'll discuss in the next class. Right, so in today's class, we'll first discuss the majority element question that we discussed in the last class, and then we'll solve one more problem which will be based on a two-dimensional array. Okay, so the problem that we left unsolved in the last class was that you are given an array and you have to find the majority element of that array. The problem says that you are given an array, and in this array you have to find the majority element. Okay, the majority element is an element which is occurring more than n by 2 times, more than n by 2, where n is the size of the array. Okay, so if the array size is 9, the element has to be there at least 5 times. Okay, it is possible that there is no majority element in the array, because there might be a possibility that there is no element which is occurring more than n by 2 times, right? Correct. So the brute force way to solve this problem as proposed by Sai is that you run 2 loops, and for every element you check the number of count of that element in the array, right? So you will start from the first element, you will select this element, then you will check in the remaining part what is the total occurrences of this element. Okay, you can then see if the total occurrences is greater than n by 2, you can return it. Then you will check for the next element, then you will check for the next element, and so on, right? So you will have 2 loops. One will be selecting a prospect candidate, the other will be checking if that element is a majority element or not. This approach is going to cost you order n square time. Okay, we discussed a more optimized approach also, which was involving a hash map. If you use a hash map, what will be the time complexity? If you use a hash map, since in hash map you can store a key value pair, right? So a hash map is nothing but a key value pair. If you are using Python, you can think in terms of a dictionary, right? So key can be your array element, and the value can be the frequency of that array element. So you iterate over the array once, and you keep the count of frequency of all the elements in this hash map. Once everything is done, or while calculating the frequency only, you can just check if there is an element which occurs more than n by 2 times. If any element occurs more than n by 2 times, then you can return it. Okay, so this approach is going to cost you order n time, but order n space as well, because you will be using hash map. Okay, how to create hash map in C? You can use unordered map in C. Now, the question here is that we have to solve this problem in order and time complexity without using any extra space. So we have to solve this problem in constant space complexity without using any extra space. Okay. Okay, so most of you are saying that now you will apply the Moore's voting algorithm, which is absolutely correct. Okay. Okay, we have one more approach. The other approach says that you first sort the array. If you sort the array, since the majority element is going to occur more than n by 2 times, right? And once you sort the array, all the similar elements will be arranged together, right? So some similar elements will be there. Then if there is a majority element, then it will also be there, and then some different elements of similar type will be arranged together. If there is an element which is occurring more than n by 2 times, once you have sorted this whole array, either you can do a linear iteration, or maybe you can just check the middle element and check the count of that element as well, right? So if you sort the array, what will be the time complexity? If you are using the most efficient sorting algorithm, even after that, what is going to be the time complexity of sorting the array? It's going to be order n log n, right? You can use quick sort, merge sort, or heap sort, right? And all these sorts are going to run in order n log n time complexity. If you are not sure about all these sorting algorithms, we will be covering them in the upcoming classes. So don't worry about it. If you already are familiar with the sorting algorithms, then you can sort this array, and then you can iterate over the array and count the occurrences of all the distinct elements, right? So in that case, the time complexity is n log n, which is absolutely greater than order n, right? So this is again not an optimal approach. Okay, so let's discuss the idea behind the most optimal approach for this problem. Okay, let's try to change the perspective. So first, let's consider an example. Let's take this example only. Okay, so if there is a majority element, the question says that the majority element will be occurring more than n by 2 times, right? The count of majority element is always going to be greater than half the size of the array. If there exists a majority element, can I say that the collective counts of all the other elements will always be less than n by 2? If majority element exists, if there is a majority element, can we say that the count of all other elements combined will be less than n by 2? Obviously, yes, right? Because half of the array has been occupied by the majority element. If you collect all the majority elements together, starting from the 0th index, and if this is the n by 2 mark, the majority element will definitely occupy, starting from 0, it will go more than n by 2. Right? So the remaining space that is left in the array is obviously less than n by 2. Correct? Okay, now if this is the case, if everyone is convinced that the count of all the other elements combined is going to be less than n by 2, now let's try to see this whole scenario in terms of, let's say, election results. Okay, let's actually consider all these array elements as the results of an election, result of different constituencies. Okay, so these are different parties. This is a party 4. This is a party 3. Okay, and let's try to see in terms of the election results. Okay, so the party to which the majority element belongs, okay, in this case is going to have 1, 2, 3, 4, 5. 5 constituencies have been won by the majority element, right? And if we collect all the other elements together, this is going to be 1, 2, 3, 4. Okay, so we have some other element A and some other element B, right? So these are the results from different constituencies. These 5 constituencies have been won by the majority element, and all these are won by different candidates. Okay, so if you remember the 2019 general elections, there was a party BJP which was in majority, and then there was something called as Mahagathbandhan, right? So in Mahagathbandhan, there were various parties which they combined hands and they were fighting against BJP all together, right? So you can just assume that these all are the constituencies won by the Mahagathbandhan, and these all are the constituencies won by BJP. Now, if the election commission says that 2 out of all these constituencies are being disqualified. There has been some cheating in 2 of these constituencies. So we are removing the results. We are not counting the results of these 2 constituencies. So if the election commission says that one of BJP's constituency and one of the Mahagathbandhan's constituencies will not be counted in the election result. If these 2 are removed, who is going to win the election? If 2 constituencies here are removed, who is the new winner? Initial winner was BJP, right? Now who is the new winner? You can quickly count the total votes and quickly see who is winning it again, right? It's still BJP, right? So what we have done, if you look in terms of this array, you have removed one occurrence of the majority element, and with that you have also removed one occurrence of a non-majority element, right? So we have reduced the size of the array by 2, and the occurrences of the majority element has been reduced by 1. Okay, let's say 2 more constituencies were removed. So one from BJP and one from Mahagathbandhan again were removed. Who is the winner? Who is the new winner now? It's again BJP, right? You can quickly see that it is still in majority. It is still having a size more than n by 2, right? So what we have done here is we have removed one occurrence of the majority element. With that, we have also removed one occurrence of a non-majority element. Okay. Again, if you do the same thing, you can see that BJP still remains in power. If you remove 2 more constituencies, we have only one constituency left, which is of BJP. So the idea is that if with every occurrence of the non-majority element, if you remove one occurrence of the majority element, at the end, you will be left with at least one occurrence of a majority element. So the idea here is that if I am removing one occurrence of any non-majority element with one occurrence of a majority element, the majority element still remains the same. Let's try to see it from other analogy as well. Okay, one another analogy could be that there are 2 countries, or let's say there are 3-4 countries, and 3 countries are fighting against one country combined. So there is a country C1, there are country C2 plus C3, and let's say C4. Okay, now C1 has got majority of soldiers, right? So the soldiers that C1 has, let's denote them as S. So let's say it has got 7 soldiers. Okay, and all these other countries combined, okay, or let's say that let's represent all these soldiers by I. Okay, then we have some more countries, and we have 3 soldiers in the country C, or let's say 4 soldiers in a country C. We have 2 soldiers in a country P, and we have 1 soldier in a country B. Okay, now since initially the number of soldiers in the country C1 have outnumbered all the soldiers in all the other countries combined. Now, if one soldier here dies with one soldier of any of these countries, who is going to have majority of the soldiers? Will that change? So initially C1 is in majority, right? Now, very similar to what we saw in the election, if this soldier dies with this, if these 2 kill each other, still C1 has got more number of soldiers, right? Actually, here we have 1 less soldier. Now it is in majority. So initially it is in majority, right? Now if one soldier of C1 kills or dies with one of the soldier of all these countries combined, still C1 is in majority. The idea is, if you are removing one occurrence of the majority element with one occurrence of any other element, the majority element still remains the majority element. Can we use this idea to solve this problem optimally? Let's now bring back our example again, and let's try to do a dry run on the example. So we have all these numbers. Now, if I remove one occurrence of the majority element with one occurrence of any other element, let's see what remains the result. Okay, so if I'm removing 4 with 2, 4 is still the majority element of this remaining array, right? If I remove 3 with 4, again 4 is the majority element, right? If I remove 3 with 4, again 4 is the majority element, and finally we are only left with 4. Okay, cool. Now the question is that you don't know initially which one of these is the majority element, right? If you don't know which one out of these is the majority element, how are you going to cancel the occurrences of all the other elements with the majority element? The question is, do you need to know the majority element? If I slightly change the initial observation, so initial observation was that if we are removing one occurrence of a majority element with one occurrence of a non-majority element, the majority element remains the same. But if I change this observation to, if I remove two distinct elements at a time, if I remove two distinct elements at a time, the majority element remains the same. Will this also be correct? If instead of always selecting one of the majority element, if I'm selecting any of the two elements, making sure that the two elements are distinct, that is also going to cause the same effect, right? Because if you are not selecting one of the majority element, then this will definitely be in majority because you are not removing it, correct? So you don't need to know the majority element initially. Okay, what you need is what is the current element that you have. Okay, and what is the count of other elements. So if we are here, if you are trying to find the majority element in this array, you don't need to sort, you don't need to get the counts of all the elements. What you can do is you can just maintain a variable and you can maintain the count. So initially when you are at 3, you can say that 3 is your majority element, count is 1. When you get another occurrence of the same element, you can just increase the count. Now you get a different element. When you get a different element, you can say that since this element is not same as this majority element, you can remove these two occurrences from the array. So you are not counting it and you are changing this count to 1. So this means that you have removed one occurrence of 3 and you have removed one occurrence of 4. Then you go to 2. Again you get an element which is not same as the current majority element. So you will cancel out both of them. So now you are removing this occurrence of 2. So you are not counting it and you are also reducing this count from here. Okay. Then you go to 4 and now you see that 4 is the new element and the current count of majority element is 0. That means if count is 0, there is no element that you have here, right? So now you can change your majority element to 4 and the count now becomes 1. Okay. Then you again go to 4 and you see that this is same as the initial element. So you will now increase the count from 1 to 2. You go to 2, you find that this is a different element, you can remove the counts. So if you remove the counts, you are not counting 2, plus you are decrementing the count of current majority element. Then again, you see that here you have 4. So you will increment the count. Again, you get 4, you increment the count. The final element that you are getting with non-zero occurrences can be your majority element. Okay. Great. If this is clear, will this always be the majority element? Will the final element which we are getting, is it always going to be the majority element? No, not necessary. This is not necessary that this element is always going to be the majority element, because there can be cases where there is no majority element in the array, right? This one. So in that case, whatever answer you finally get, you will have to actually count the occurrences of that in the initial array. So here if you get 4 with a count which is greater than 0, you will again you will run a loop over your initial array and you will count the occurrences of this prospect majority element. This can be the majority element, not sure. Okay, this is a prospect, this is the only candidate for a majority element. So if you get something here with a non-zero count, you will just check here and count the occurrences. If they are greater than n by 2, then you can say that this is the majority element. Okay, I will just repeat the counting part again. Okay, how we are counting. So Is everyone clear with the idea of this algo? The idea is that whenever you get two distinct elements, you remove them. Okay. If you are getting two distinct elements, you remove the occurrences of those two distinct elements. So if I'm getting 3, and then let's say if I'm getting 4, I will try to remove both of them. Okay. So what we are doing here is we are maintaining a current majority element and we are maintaining a count. Okay. So if you get 3, you increase the count. So you have, let's consider a different example. Okay, let's take an example given by Vijay Sai, which is 3, 3, 3, 4, 4, 2. Okay, so we'll be maintaining a majority element and we'll also be maintaining a count. Okay, you get 3, you say that 3 is the current majority element. I don't know what is going to be after 3, but 3 will be the majority element. Count of 3 currently is 1. Then you go to 3 again. This is same as the initial or the current majority element. So you increment the count to 2. Okay. Then you go to 3 again. You will increment the count to 3. Then you go to 4 and now you get a different number. What was the algo? What was the initial observation that we made? The observation was if you remove two distinct elements, the majority element remains the same. So if I get two distinct elements, I will cut them down. So I will not count the occurrence of 4. So I'm ignoring 4 and simultaneously I'm also reducing the count here. Okay. Then I get 4 again. I am again reducing the count. Then I'm getting another different number. So I'm reducing the count. Count becomes 0. If count becomes 0, that means there is no majority element. If let's say there was another 3 and okay, so in this case basically you are not going to get a non-zero count, but it might be possible that you can get a non-zero count even when you don't have a majority element, right? So you can have something like 1, 2, 3, 4 and then let's say 5, 5. Okay, in this case if you run the same algo, you will get a non-zero count at the end, but there is no majority element in this array. So after you get a non-zero count, you will have to check in this whole array. You will have to count the number of occurrences of your prospect candidate. Okay. Okay. Rahul is asking, will it work for n by 3 problem? Yes. Okay. So in this case, the question was that majority element should be occurring more than n by 2 times. Now there is a variation of the same question which was asked in Google, where the problem says that your majority element is an element that occurs more than n by 3 times. Okay, now using the same concept, you have to solve this problem. Okay. Yes, Ayush, this will work. Okay. If you want, you can also try to see it mathematically. Okay, you can just take an array of size n. Let's quickly see how if it is going to work mathematically or not, right? So the initial size of the array, size initial is equal to n, right? If you are removing 2 elements, then the size will be n minus 2. Now, if there is a majority element, then what should be the minimum count of that majority element in this initial array? That has to occur more than n by 2 times, right? These many times. If you have removed 2 elements, from this array, at least one of them can be the, or at most one of them can be the majority element, because you are removing 2 distinct elements, right? So the count of new majority element in this array is going to be n minus 2 by 2 plus 1, right? Is it making sense, guys? So the initial size of your array was n. After removing 2 elements, the size becomes n minus 2. Initial count of the majority element was greater than n by 2. So the minimum count would have been n by 2 plus 1. Now the count is size by 2 plus 1, right? And if you have removed 2 elements, only one of them can be the majority element, right? So what would be the new count of this element? The new count of this element is going to be the initial count minus 1. This is going to be n by 2. Okay. And if you solve this, this is also going to be n by 2. So you can see that this is the count of majority element which should be there in this array of size n by n minus 2, and this is the count of the initial majority element. So you can say that the initial element still remains the majority element. Now you can do the exact same exercise for n by 3 also, and you can check whether the same algo is going to work or not. Okay, what is the time complexity of this whole algo? So we are running a single loop, right? We are running a single loop and we are just maintaining the current majority element and the count. Okay. So the single loop is going to count you order n time complexity. What about the space? We are using only two variables, right? We are not using any array. We are not using any hash map. We are using only two variables. So the space is going to be constant. So will you be able to write the code for this? Could you go through an example of n by 3? Example of n by 3 is there in the test that you have received yesterday, right? You can just go through that problem and examples are listed there. You just have to check using this exercise that will the same approach work or not. If you are able to do that, then you can solve that problem as well. Okay, let's solve the next problem. Now the next problem is also a very interesting problem. Yes, the algo that we have discussed, this is the Moore's voting algorithm. Okay, so let's discuss the next problem. In the next problem, you are given a matrix. Okay, this matrix is sorted row wise. All the rows of the matrix are sorted, and all the columns are also sorted. Okay, what is a matrix? Matrix is nothing but a two-dimensional array. Okay, so all the rows are sorted in ascending order, and all the columns are also sorted in ascending order. So here we have a matrix which is sorted all. So you can just quickly observe all the rows are sorted in ascending order and all the columns are also sorted in ascending order. Okay, you are given a target and you have to search the target in this matrix. Okay, so for example, if your target is 37, you have to identify whether the target is present in this matrix. If it is present, then what are the coordinates? Okay, so if the target is 37, 37 is present and it is present here, right? So you will be returning the coordinates of 37 in this matrix. Okay, is the problem clear? Okay, for those for whom the problem is not clear, I will quickly repeat it again. You are given a matrix where each row is sorted in ascending order and each column is also sorted in ascending order. Okay, then you are given a target and you have to find and return the coordinates of the target in this matrix. The dimensions of matrix is n cross n. Okay, what is the brute force here? Can everyone solve this problem using a brute force algorithm? We simply have to start from here. Okay, then traverse all the rows, each and every element, check if that is equal to the given target or not, right? If you do this, what is going to be the time complexity? If you are traversing each and every element, how many elements are there? This is going to be order n into n, right? There will be one loop which will run from 0 to n, then there will be another loop inside that which will run from 0 to n, right? Okay, now some of you are saying that you can solve this problem using binary search. Now, for all those who don't know how binary search works, you can just skip this part. We will be covering binary search in details in the upcoming classes. For all those who know how binary search is going to work, can you guys quickly think of an approach which uses binary search? See, all the rows are sorted. Okay, if all the rows are sorted and you have to search an element in sorted rows, can you use the fact that the rows are sorted? Yes. So in each and every row, you can apply binary search, right? What is the time complexity of doing binary search on an array of size n? If you are running binary search on an array of size n, the time complexity is log n, right? And if you are doing binary search in all the rows, how many rows are there? So in this case, we have n rows and the size of each and every row is n, right? So in our case, if we apply binary search on every row, if you apply binary search on each and every row, what will be the time complexity? There are n rows and there are m columns. So there are m elements in each row, right? So this is going to be the time complexity. Okay, cool. Can we do better? Okay, if we want to do it, if we want to do better, let us try to make some quick observations. Okay, if this is the matrix, let's draw a matrix here. Where can we find the smallest element of this matrix? Can you guys quickly tell me the coordinates of the smallest element present in this matrix? The smallest element of this matrix is going to be at 0, 0, right? This is the smallest because all the rows are sorted, all the columns are sorted. So this is the smallest of all. Where can I find the largest element of this matrix? The largest element of this matrix is correct. It's going to be at the cell n-1, n-1. This last cell, right? This is going to be the largest of all. Now, if the target element is smaller than 0, 0, or if the target element is larger than this element, can I directly say that that element is not going to lie inside this matrix? If your target is less than 0, 0, or your target is greater than the last element that you have, which is present at n-1, n-1, can we say that this target is not present in the matrix? Yes. What if this is inside the range? What if the target is inside the range? So if we are starting from this point, if the target is greater than 10 and it is less than or equal to 71, and I'm starting my search from this point, can the target be present in this row? If it is greater than 10, can the target be in the first row? Yes, because all the elements of this row are greater than 10, right? So target can be 30, it can be 40. Target can also be 17 or 15, right? So it can also be present in this column as well. So if the target is greater than 10, it can be present anywhere in the matrix, right? If we are starting the search from here, we are unable to make any conclusive decision because all the elements here and all the elements here are following the exact same property, which is that they are greater than 10. So this is not allowing us to discard any of the search space, correct? Let us start the search from this block. Now, if the target is smaller than this, can I say that the target has equal chances of being present in this row, in this column, as well as in the last row? Because all the numbers in this column are smaller than 71 because the column is sorted in ascending order, right? All the elements of this row are also smaller than 71. So again, we don't have any decision that we can take, right? We cannot discard any part of the search space. All the values are still relevant. Okay. Let's try to search from this point. Now, can you guys figure out a pattern? If I'm standing at this point, if I'm standing at 50, what can I say about all the elements present in the first row and all the elements present in the last column? If this row is sorted in ascending order, can I say that all the elements of this row are going to be less than 50? Similarly, all the elements of this column will definitely be greater than 50. Is it going to help us make any decision? So if the target is less than 50, can I say that target will never be present in the first column? If the target is less than 50, the column is sorted in an ascending order, right? If the target is less than 50, all the elements in this column are definitely going to be greater than 50. So the target will never be present in this column. Now I am able to make a decision to discard some part of the search space. The search space has become smaller, right? All these values are now irrelevant. Okay. So if the target is less than 50, I can directly move to this cell and I can start comparing from this cell. Now, if the target is greater than 40, can I say that that target will never be present in the remaining part of this row? If the target is greater than 40, I know that all these elements are less than 40 because the row is sorted in ascending order, right? So now these elements become irrelevant for us. So I can discard this complete row. Okay, and now I can start my search from this cell which has 45. Again, I can check whether the target is smaller than 45 or greater than 45. So at every step, I am able to make a decision of either discarding one row or discarding a column. So let's say that if the target that we have to find is 26. Okay, if 26 is the target that we have to find, at this step, I know that 26 is smaller than 45, and since this column is sorted in ascending order, all the elements below 45 are useless, right? 26 can never be present in this part because 26 is smaller than 45. So I will move my pointer to 35, right? Now, when I'm at 35, I know that again 26 is smaller than 35. So all the elements of this column also are useless for us. Okay. So we move to 25. If currently I'm standing at 25, I can see that 26 is bigger than 25. If 26 is bigger than 25, all the elements present here are useless for us, right? So we move down. Now, when we move down, we figure out that this element is nothing but the target. So we have found the target. So in every step, we are either able to discard a complete row or we are able to discard a complete column. So you will be running a loop. You will be starting from the topmost corner, right? You will be starting your code. You will be starting your search from this top right corner. And you can say that if this element is equal to the target, then you can directly return true, or if you are asked to return the coordinates, you can do that. Now, if this element at the top right corner here is smaller than the target, then what can we say? We can say that all these elements are if this element is smaller than the target, then these are useful, but these elements are useless because these all elements will also be smaller than the target, right? So what can we do in this case? We can just switch to the next row. So we will be doing I++. Okay. Else, if this is greater than the target, then what can we say? If this element is greater than the target, then all these elements will also be greater than the target. So we can switch the search space, or we can switch the column to the previous column, right? So we can move to the previous column. So that will be J minus minus. Okay. And there will be a while here. Can you guys tell me what should be the condition which should come here when we have to stop all these things, when we have to stop the search? If we find the target, then we are returning. So that will obviously break this while loop. But what should be the condition? What should be the boundary cases for this search? We're starting the initial I value from where we are starting is 0, right? This is the first row from where we are starting. The initial column value is the last column, which is m minus 1. So these are the initials from where we are starting. Now, what should be the restriction, or what should be the boundary where we can go? This I. So now you can also pay attention to how we are changing these variables, right? So I is always getting incremented, j is always getting decremented. I is currently at the smallest possible value, which is 0. J is currently at the largest possible value, right? So if you are incrementing I, you have to make sure that you are not going out of this matrix from here, right? So I should always be less than n. Okay. And if you are decrementing j, you have to make sure that j does not become less than 0, right? So j should always be greater than or equal to 0. So this is your boundary case till which you have to run this loop. And if you find the target, it's good, return true. If this current element is less than the target, all the elements of the first row will also be less than the target. So ignore them move to the next row. If this element is greater than the target, then all the elements of this column will also be greater than the target. So ignore them, move to the previous column. Okay. And we search the element. What is the time complexity? Some of you are saying log of m into n. Is it log? What is the time complexity? So to get to the time complexity, focus on what is the maximum number of steps that you are going to take. Right? What is the maximum number of values that I and j can take? I is starting from 0, it can go till n. J is starting from m minus 1, it can go till m. So what is the total number of combinations of these values that can be there? In every in other terms, you can also think in this way, that in every step, either you are ignoring one row or you are ignoring one column. There are total n rows, there are total m columns. If in the worst case, if the target that you are finding is present here, you will be ignoring all the rows above this and you will be ignoring all the columns after this, right? So the time complexity is going to be n plus m. What if matrix is not sorted? If the matrix is not sorted, you cannot apply this logic, right? Why not maximum of n and m? That is because you can do both of the things, right? If you are moving from this corner to this corner, you will have to take all the n steps in order to move from here to here, and you will also have to take all the m steps in order to move from here to here. This is the worst case, that you go down as much as possible and you also go left as much as possible. Okay, so that is n plus m of every row. Okay, Vijay, you can just try to see some of the example. Just try to dry run your approach on this matrix itself. You will find that chances of finding your element in every row will be there. So if, let's say, I am talking about, if I have to find 30 is smaller than all these numbers, right? So 30 can be present in any of the rows. 30 is greater than the first number of all the elements in the first column. 30 is less than all the numbers in the last column. So 30 has got a chance of being present in each and every row. So you will have to apply binary search in every row. And if you are applying binary search on each and every row, then that will be n log m. Pseudocode, we have written the pseudocode, right? This is the pseudocode. Oh, this is the actual code, not the pseudocode. This is how you are going to initialize your I and j, I from 0, j from m minus 1. Okay. And I hope you have learned something in today's class. Please do solve the problems and please do subscribe to the channel so that you don't miss any new class update. Okay.